Okay, the next little mini lesson here is what happens when you need to multiply radical expressions. This is going to be connected to the IXL EE6. Again, the last ones were EE5 and EE5. This is the lone one all by itself, EE6. All right, so basically we're doing the distributive property. Okay, we're taking a radical on the outside times a radical and a number on the inside. So basically we're doing this. U times U and U times U. Now, shortcut here really quick. Remember, when you take a radical times a radical, you can write it as a super radical. That sounds really neat. So 10 times 6 is 60. Okay? That's no different than if it was 10 times 6. They're just underneath the radical sign. That's fine. That is 10 times 6. Now, the nice and super duper easy thing is when I take a radical times a number, all you do is you mush them together. Okay? That's no different than if I took a variable times a number. Remember, back in the day, when you took numbers times variables, all you did was you smushed them together. So like over here really quick, if I took 3 times x, that's just 3x. Okay? Same thing here. 3 times the square root of 10 is just 3 mushed up against the square root of 10. So what I'm going to try to do now is I'm going to try to do what I did here. I'm going to try to rewrite this. Hopefully I can get a square root of 10. If I get a square root of 10, then I can combine this radical and this radical. So let's see what I got here. Square root of 60, let's check my chart. Again, if you write this thing down, it's going to save your life a lot. Square root of 60, the best I can do is rewrite it as 4 times 15, which is 2 square roots of 15. So the best I can do is 2 square roots of 15 plus 3 square roots of 10. And that's it. I can't go any further. Okay, I'm stuck. Yes, I could rewrite that as 3 times 5 and 2 times 5, but that I can't get anything out of the radical sign. There's still going to be different radicals. That's 5, that's 10. Apples and oranges, they're different. I got 2 of these and 3 of these. I can't combine them. They're different. That's the best I can do. Okay. Next one. Let me replay that really quick. Okay, let me replay that. So again, 10 times 6 is 60. They're both radicals, so they stay radicals. This is a radical. This is a regular number. They mush together. I can't rewrite that. I can. And then I just can't simplify. So sometimes you can simplify, sometimes you can't. Just depends what you get. Okay, next one. Times U times U. Okay, so I'm going to have a negative 4 squished up against a radical of 3. And then I got a radical of 3 times a radical of 3 with a plus sign right there. So plus square root of 3 times the square root of 3 would be the square root of 9. Or wait a second, I need 2 radicals to make a regular number. Square root of 9 is 3. That's simplified. Negative 4 rad 3 plus 3. Now that's okay for me, but some mathematicians prefer to put the nicer number first. So this is okay. Or you could write it as 3 minus 4 radicals of 3. Okay, I think some mathematicians prefer this way better. But mathematically it's the same thing. If you type both these things in the calculator, you're going to get the same decimal. Okay, so that's it. That's multiplying radicals. Just remember your square root rules. If you take a square root times a square root, you can make a super square root. If you take a radical times a number, you just mush them together. Okay, and then you try to simplify best you can. And if you get stuck, you're done. If you can rewrite, you can rewrite. Okay, that's about it. That's the multiplying radical expressions. All right, peace out.